Welcome to the Scribblecast on linear functions. Today our outcomes, what we'd like to accomplish is to be able to find the slope and y-intercept of line, graph equations, and then determine equations of lines given particular characteristics. We'll also take a brief look at parallel and perpendicular lines. To begin with, though, we're looking at linear functions, something that in other courses you probably would have looked at lots before, and you probably would have seen characteristics of lines before too. But just as I guess, a template or a model of things to come. Typically when we're looking at math, yes, we deal with lots of x's and we play around with those. But really what we're doing that for is so that we can model something that happens in real life. Typically, this is a process that happens in real life, that we collect some data, then we graph it. So here's a graph, and we'll graph our data, and then we try and compare it to an established model. One of the established models is a line. So this particular data here might sort of approximate a straight line. Then with that established model, we maybe try and explain and predict something that is happening in a particular situation. I guess initially we identify a problem or a relationship that happens between data, collect the data, graph it, compare to an established model, and then explain and predict. And that's where the power comes from in math. Here's some examples of some established models. So linear functions, quadratic functions, you would have played with those before. Those are guys that have an x squared plus something in them. Cubic ones that have the x cubed, linear ones, we've seen those. Logarithmic functions, ones that would have some kind of log in them, log of x or something. Sinusoidal, this particular one is a sine graph, or exponential functions, but there's a lot of different type. Another one, absolute value function. There's lots of different ones, but we try and get data, try and approximate them to one of these established models, and then from that we can predict. Just as a quick little example, looking at how much income tax you pay based on how much money you make. So in Canada right now, it's about, if you make less than $10,822 in a year, you don't have to pay any taxes. But the more money that you make, say you make $20,000, then you're going to have to pay a little bit more taxes. Say you get $30,000, you're going to have to pay more taxes. And you can probably see that if you plot enough points, I should have used a straight line there, they approximate a linear function. And so what that allows us to do is explain and predict. Or we could say, okay, if you make $100,000, you would probably pay this much in taxes over here. And that's our explain and predict part. Lots of variables in this particular example, and there are in any kind of real world example, lots of variables. And so often we're predicting just a part of a whole graph. Let's look specifically at linear functions. And we're doing these just because you've seen these before, but we're doing this just as a type of things to come. So we'll do the same thing with quadratic functions, cubic functions, logarithmic functions, sinusoidal functions, exponential functions, etc. So in this course we'll do similar kinds of things. If I have a linear function, lines can be defined using basically two characteristics. And you've probably seen them before. So I can define any line based on its slope and based on its position, or the place where it crosses the y-intercept. We actually have letters for those. Slope, we have a M for slope, and y-intercept we use the letter B to indicate those. But it doesn't matter where your line is, you know, where it was, or here, or if I change it and maybe it's got a higher slope, or maybe it's got a negative slope. I can describe any line based on what its slope is and what its y-intercept is. So if I can do that, then that gives me an advantage in both graphing these, but also looking at equations for them. Here's some of the tools you would have seen in the past that deal with lines. So this formula here is one that allows you to determine the slope of a line. That's what M stands for. Based on if you have 2 points that are on that line, this is just the general base formula for determining or for writing a linear function, y equals mx plus b. Here's another one. This is called the point slope formula, where you can determine the equation of line if you're given a point, that's the x1, y1 part, and m slope. Also, if you know that something's a horizontal or a vertical line, or if you know they're parallel or perpendicular, that gives you additional information on the line. So let's just try a couple of examples where we use those tools to help us out. First question here, it says 2 points are given, -2 and 1, 3 and 5. They want us to determine the slope between them. So to determine the slope, I can use this formula, and I will in a second. Another way I could do it is slope basically is how far do you have to go up over how far you have to go over this way. So if I look at this one, I have to go up 1, 2, 3, 4. So I'm going up 4. And then I'm starting at -2, ending at a +3. So it looks like that run over there is 5. So my slope, I could write as rise over run. And the rise is 4, and it runs 5. So I could say that that's my slope. I can also use this formula over here. When you use a formula, make sure you identify your points. So x1, y1. Each point has an x value and a y value. x2, y2, and then just plug them in. y2 is a 5, minus y1 is a 1, over x2 is a 3, minus x1 is a -2. Ooh, got to be careful with that right there. So if I take away 1 is 4, 3 minus a negative, notice that those will cancel, so it'll be plus, is 5. So I'm getting the same slope. Now that's one characteristic of my particular graph here. I could, if I wanted to, also determine what the y-intercept is, where it crosses the y-axis. It looks to be about 2.5, but we'll maybe do that in another question. So here's one where they say find the slope and the y-intercept from the following equation. If they already give me an equation, and if that equation is already in this y equals mx plus b format, then I can just draw the slope information and the y-intercept information right from the equation. So there's slope and there's y-intercept. So I could say slope is equal to a -2.3, and the y-intercept is equal to a +4.2. If I wanted to graph that, y-intercept's 4.2, 1, 2, 3, 4, so right about there. And the slope is -2/3, so it's got to be sloping this way. So -2.3, so I'd go up 2.3, and I'd go over to the left 1. Because any slope you could write as a fraction, right? So you could go up 2.3 over 1, something like that. And so my line would be something like that one. Okay, they actually just told me to find the slope and the y-intercept, but I gave them a graph too. Okay, here's a question where it says find the slope and the y-intercept. I look at the equation and it doesn't look like this one. And this is part of the game of all of the functions that we'll look at in this course, or any of the relationships, is I might get an equation that doesn't look like the normal equation. So what I have to do is make this one look like that. So I see a y here and an x, but the x is supposed to be on the other side. So I'll subtract 3x here. I can do that as long as I do it on both sides. So on the left side, I'm left with -2y. On the right side, I'm left with a -3x plus 12. Notice I wrote the 3x one first here. Often I guess you could write 12 minus 3x. But the format has the x first, so I just put that first. It also just has a y there, so I have to get rid of this -2. It's being multiplied, so I'll divide everything by -2. Divide -2, divide -2. Notice you have to divide everything. On the left side, I'm now stuck with just a y. On the right side, the 2 minus will cancel, so I'll have 3/2 x. That's in the slope spot, so I know my slope is 3/2. And then 12 divided by -2 is a -6. That's in my b slot, and so I know that my y-intercept is a -6. to graph that. Y-intercept down here at -6, that's where it crosses, right there. The slope is 3 over 2, so I could come up 3 and go over 2, and I'd have a point. Up 3 over 2, I'd have another point. And I could draw a line between those. That would be the graph of this function. Okay, lots of different ways that you could determine equations of lines given some information. If they tell you what the slope and the y-intercept is, well, I'm just going to be using that guy right there. And all I do is I plug the slope in, that's m, in this case -2, wherever that m is. And then I put an x. They say the y-intercept 0, -3, so my y-intercept is -3. Done. If they ask me, like in this question, if the slope is 2/3 and the line passes through this point, a number of different ways you could do that. So in this example, I know what my slope is, and then I know that it passes through a point. But this point here isn't a y-intercept. So this isn't, it's not b. So like in this one here, I knew what my slope was, and this was b, so I could slide it in there. But if this isn't a y-intercept, then I got to find that. A couple ways you can do that. I like using this formula here, the point slope formula. But it turns out that you could just use this formula, plug in a point for x and y, that would be 3 and 7, plug in a slope, that's this one, and that would find you the y-intercept. You could do that too. This equation works well for me. So y minus y1 equals m times x minus x1. So y, I don't plug anything in for that, minus y1 is whatever y is here. So this would be x1, y1. So that would be 7 equals, the slope is 2/3, times x minus x1 would be from right here, right at 3. And now all I'd have to do is, this is an equation. So if they say write an equation, I'm done. But typically if they say write an equation for a linear function, they want it to look like this one right there, the y equals mx plus b. So I probably should rearrange this a little bit. Let me go down a little bit. So I'm going to, might need more room, y minus 7 equals, I'm going to distribute this 2/3 in. So it'd be 2/3 x, 2/3 times a minus 3, I think it's just -2. Then I'll go up here, and I'll move the 7 over to the other side by adding 5 on each side. So it'd be, or adding 7 on each side. So it'd be y is equal to 2/3 x, and then -2 plus 7 would be plus 5. So now I've got the equation in the right format. Okay, here's my slope, here's my y-intercept. If I wanted to graph it, y-intercept is 5, I could go up 2 over 3, there'd be another point. Up 2 over 3, another point, draw a line. This last example of writing an equation like this, y equals mx plus b, from some information, is if they give you 2 points. If they give you 2 points, then immediately what you can do is find the slope between them. Slope is y2 minus y1 over x2 minus x1. And as soon as you get the slope for a line that passes through these 2 points, then the question is exactly the same as the one above it. Because I have a slope and I have a point. In this case, I actually have 2 points. So I could use my slope that I get here and use at this point, or I could use that point, either of them. Well, and actually it'd be a good idea to try both of them. They should both come up to the same answer. Okay, so those are some examples of how you could, given some characteristics of a graph, write an equation. Now, when you're graphing any linear function, typically they give you a formula that looks like this, and they're asking you to graph it. You always start graphing with whatever the y-intercept is. If they say the slope is 3/4, yeah, that's great, but all that tells you is, maybe I'll draw a line, I could go, say from any point, I could go up 3 and over 4, 1, 2, 3, 4. So that would be this information right here, the 3/4, this would be a slope of that line. But it doesn't tell me where it is. Like, I need to be able to know where it is. So I like to start drawing a line from here from my y-intercept. So I'm going to identify the y-intercept at -2. I'll put a dot down there. And then from that dot, I'm going to use my slope to get a second point. So I'm going to go up 3, 1, 2, 3, and over 4. 2, 3, 4, right there. So that is my exact line. It goes in between there and there. I guess I can extend that. Doesn't matter how long I put it. It doesn't have to start and stop at those points. But that would be my line. Goes through this y-intercept, and it has a slope of rise 3, run 4. Sometimes when you have some particular lines, we have some special occasions with them, where sometimes I have lines that have a similar slope to them. So like these two here lines, the red and the blue one, they have a similar slope, but they cross at a different y-intercept. If that happens, what you have is you have parallel lines. And they might ask questions about that. They might say a line is parallel to this other line. And the only information that they're giving you from that is that they have the same slopes. So if I have a line that's parallel to a line where they give me the slope, it means the slopes are the same. But that they have different y-intercepts, so they cross the y-axis at a different spot. Perpendicular lines, on the other hand, they don't have the same slopes, of course, but they have what we call a negative reciprocal of slopes. So say the slope of this red line is 2/3, then if this blue line is perpendicular and has to be perpendicular, I like to write the perpendicular line like that. So it looks, the slope of a perpendicular line is equal to the negative reciprocal. So if this one's positive, my perpendicular line has to be negative. And then reciprocal means I have to take this fraction and flip it over. So the slope of the red line is 2/3. A slope of a perpendicular line to that one is -3/2. And again, they could ask you that in a question. If you have a line and here's its slope, I want to know the equation of the line that's perpendicular to that one. As soon as they say perpendicular, then just take the slope and change it like we did right there. Okay, so we have gone through in this section the whole idea of a linear function. We went through some ideas of modeling. We also went through a number of ways where you can come up with this equation, and where this equation gives us some information about, in this case, a linear function. So probably now would be a good time for you to go and try some questions in the book.